Station, this is Houston. Are you ready for the event?
Houston Station, ready for the event.
Coconino High School, this is Mission Control Houston. Please call station for a voice check.
Station, this is Coconino High School. How do you hear me?
I have you loud and clear. It's nice to talk to you today.
Good morning. My name is Christine Sapio. I'm in Flagstaff, Arizona with 600 students who are eager to learn about your experiences on the space station. Here comes our first question.
Hi, my name is Simon, and I'm a student at D. McClain Elementary. My question is, does the International Space Station move due to the Earth's gravity, or does it need to propel itself?
Well, that's a great first question, because it basically is the same question as how did we get up here on the International Space Station? So the International Space Station is a giant international science laboratory that was put together by a lot of different countries. We're about 250 miles off of the surface of the Earth. So when you think about 250 miles, it's really not that far. You could drive that in your car in about 6 hours. But to get from the surface of the Earth up to a 250-mile orbit, you need to hit escape velocity to get out of the Earth's gravity. And so the first thing we have to do is accelerate to about 7 miles per second. And then the velocity that we are going forward is determined by the orbit that we want to go in. So objects that are moving faster are at a higher orbit or further from Earth, and objects that are slower are a little bit closer. And so we are going about 17,500 miles an hour. And so you can imagine if we had to propel ourselves at that speed, it would take a lot of fuel. But what an orbit basically is that we are actually free falling toward Earth, but we are matching the curvature of the Earth as we go over it. So if you think about throwing a baseball, if you throw a baseball really gently, it lands not too far away. If you throw it even farther, it goes farther and then it curves back down and hits the Earth, right? So if you threw that baseball hard enough, there is some speed at which its curve back down to the Earth is going to match the curvature of the Earth, and it's just going to free fall around the Earth. So we're just constantly in free fall. And for our orbit at 250 miles above the Earth, it's about 17,500 miles an hour. So no, we don't have to propel ourselves once we get up here, but it took a heck of a lot of fuel to get here.
Thank you. Go ahead.
Hi, my name is Casey, and I'm a student at D. McClain Elementary. And my question is it ever hard to get around the spacecraft?
Yeah, I tell you, we make a lot of rookie mistakes when we first get here. And so you can see this is, if I reach my arms out, that's about how wide our walls are. And so if you notice, I can't touch this wall and that one at the same time. So there is a spot right here in the middle where I could actually get stuck not holding anything. And this is one of the early rookie mistakes, where we get a little stuck not being able to grab onto anything. But I tell you what's amazing. The human body is amazing, and your mind is amazing. And you adapt so quickly to where you are. And, we have these handrails all over the place. And, when you first get here, every time we enter a module, we have multiple different modules, which is what we call our rooms, right? We basically have a lot of different rooms. And when you first get here, when you go into a new room, you want to go, okay, which way is up, which way is down, which way is left and right? Because we're so used to on Earth kind of just subconsciously mapping all of our surroundings like that. But up here, what's really interesting is that after a couple weeks, you don't think that anymore. It's like your brain remaps in 3D, and you don't think about up and down anymore. You kind of twist and loop through the hatches. You know exactly where you're going, which way to turn. Instead of looking for up and down, the lights are up and the ground is down. You go, okay, well there's a workbench over here that I'm going that way. And so what's really neat, it's really neat to try to get used to floating, but it's really cool when you've been here so long and you're so adapted that you don't even think about it anymore, and there are days I go through it, just another work day, and it's the afternoon and I'm just like, wow, wait a minute, I'm still floating.
Great. Thank you. Go ahead.
Do I look at the screen?
Yep, go ahead.
Okay. My name is CJ and I'm a student at D. McClain Elementary. How do you stay safe in space? Thank you.
I'm sorry, can you repeat your question?
The question is, how do you stay safe in space?
Well, so the first way to stay safe, really anywhere that we go, is determining what the risks are. And so, me personally, I don't have to think about it on a daily basis because there is a huge mission control team that has thought about my safety long before I was here, and is monitoring it every single day. However, there are various emergencies that are a pretty big deal up here. One of those is a fire. One of those is really anything to do with our atmosphere, right? The air that we're breathing, that I'm breathing right now, to me it feels a lot like the air on Earth. But this air, it didn't exist up here in space. Like, we had to create it up here. The engineers at NASA had to create this air. And so they know exactly what we need to live, and they are constantly monitoring to make sure that the exact ratios of particles like oxygen and carbon dioxide and other trace contaminants are exactly where we need it to be. And so one of the risks of in spaceflight is if that balance can't be kept, and that could happen if there was a depressurization, if we got a hole in the side of space and we had a depressurization, or if one of our pieces of equipment broke and we weren't able to do that. So the way that we stay safe is understanding the risks and then training for them. And so we spent about 2 years training for this space flight, and we went through simulation after simulation after simulation. And I can tell you, we don't train very much for a normal day. We train for stuff to break. We train for stuff to go wrong. And so training is really the best way that we stay safe. So that's what I can control, is my training. The teams on the ground in Mission Control in Houston, you've probably seen pictures of all the controllers behind their consoles. They are constantly monitoring every threat to us. And so, like I said, the air was one of them. Another thing that they monitor is debris. Debris out in space. We're going 17,500 miles an hour. You've probably seen what a rock can do to your windshield when you're going on the freeway at 50 miles an hour. So it can do a lot of damage, and so they actually can track a lot of space debris, and they can move the space station. So that's another way that we keep safe, is our folks on the ground are constantly monitoring 24 hours a day.
Hi, my name is Deontay, and I'm a student at Coconino High School. And my question is, what is the type of science are you doing on the space station?
Yeah, so the science is really the key and why we're here. And science it's so much more. It's based on all the principles that you guys are learning in your science class, but it is applying all of those principles to exploration, to making life on Earth better. And so there's a couple flavors of experiments that we do up here. One of them is outside of the space station. There's a lot of experiments that we never come in physical contact with, but the folks on the ground design them, fly them, use robotics to deploy them. And so, one of those would be the alpha magnetic spectrometer, which is a really long name. We call it the AMS, and it's looking into deep space to look for evidence of antimatter that could tell us, how the universe was formed and how many other galaxies there are. So there's big experiments like that. And then inside the space station, we have human research. So we have research on ourselves and how our bodies adapt to space. And then all of the racks, which is what we call our walls, we have these racks in our walls, all up and down the side of space station are full of experiments. On any one day, there's about 300 experiments going on space station, and we may only touch 2 or 3 of them every day because a lot of them are run remotely on the ground. And I'll tell you, one of the advantages of space experiments is that we can do things up here that we can't do on the ground. One of the big significant things that we can do up here is we can grow crystals for different experiments very well. And so recently we grew protein crystals for research in Parkinson's disease. One of the reasons the scientists on the ground have had trouble learning the pathology of Parkinson's is because they couldn't grow the crystals large enough so that they could investigate it. So what we did up here is we grew the crystals up here, and then we fly them back on a cargo vehicle, and then on the ground they'll be able to look at that. And we're really hopeful that will lead to a breakthrough in Parkinson's disease. I'm sure a lot of you have been touched by that.
Hi, my name is Skylar, and I'm a student at Coconino High School. What was the training like to become an astronaut?
I tell you, the training to become an astronaut started the day I was born, and I say that in one way because I told my parents when I was just 3 years old that I wanted to be an astronaut. I'm not even sure if I knew what it meant then, but I guess that was just what was in my mind from an early age. You know, and there's kind of the technical side training, and then there's the human interaction and leadership side of the training. So to train for this mission on the technical side, I was selected by NASA in 2013. I was a helicopter test pilot in the Army at the time, and so I was already familiar with flying, just not to space, and certainly not this high. And then starting in 2013, and for 5 years, I was doing the technical training at NASA. So that's learning about the space station, learning about our Soyuz spacecraft that we flew up here, learning about all the systems, learning how to spacewalk, speak Russian, how to, you know, when you think about it, we are on this self-contained little house in the sky, and if anything goes wrong, we need to fix it. So a lot of that training was, you know, how to do plumbing and electricity, and, you know, if we snag and break a wire, how can I fix that wire? So really practical training. So that's the technical side. It was about 5 years. On the interpersonal team side, you know, I've been up here for just over 3 months with 2 other people, and we work with very large teams on the ground. And understanding how to work in teams, how to lead teams in a kind of high-gain, high-risk environment without getting complacent and being reliable, you know, all of those lessons I learned long before I got to NASA. And, you know, I'm still learning every day. But working with teams all the way from, you know, high school, junior high, up to today, all of those experiences really play into our mission now.
Hi, my name is Zachary, and I'm a student at Coconino High School. My question is, how much of what you learned in high school do you actually use?
Well, I'll tell you a secret. I use a larger percentage of what I learned in kindergarten than what I learned in high school. You know, I know how it is sitting in high school, sitting in college, and just going, man, you know, I want to go do all this, and I don't see them sitting down and doing what I'm doing right now. But here's what I kind of figured out. What you're learning in high school is not only the subject material that you're learning, but you are also learning how to learn. And you are demonstrating your maturity and your level of responsibility by how dedicated you are to it. Because one thing I do know is that there's no such thing as smart people. You know, yes, some things come to some people a little bit quicker, but if that is not followed up by hard work and determination and dedication and maturity, then it's not going to go anywhere. And so the biggest thing in high school that you can, you know, don't go to school and think, you know, what am I going to take from today? Go to school and think, I am showing myself off right now. I am showing everybody what my character is. And so the big thing in high school that you can really show and learn how to do is to have the maturity to do what is required of you, because no matter what your job ends up being and no matter what dream you end up pursuing, you're going to have to do things sometimes that you don't like. You know, even in my current job, you know, there's things that I do on certain days that I don't enjoy, but, you know, you have to have that maturity, and learning how to work hard is really big. I'll tell you a real quick story. When I was in college, I was taking a physics class. And this physics class was really hard, and it was known for having the worst tests in the world. And so I was super nervous for it because I knew I wanted to do well. And so about 4 days before it, I started studying like you've never seen before. Like, I don't think I slept for those 4 days. I was up all night. I reworked every single homework problem, every single drill problem. I read every single chapter in the book. I mean, I studied so hard for those 4 days. And when we took that test, I ended up getting just under 100%, and the average grade across all 1,000 cadets at West Point was about a 78. So I was a lot higher than them. And I remember a friend coming up to me and saying, I wish I was smart so I didn't have to work hard like you. And it was at that moment that I realized, you know what, it's not about being smart. It's about digging deep, and studying hard. And I tell you, that is what you can learn in high school. In addition to the subject material, which will be the basis for everything you do, you can learn how to work hard.
Hi, my name is Caleb, and I am a student at Coconino High School. And my question is, what is it like to experience re-entry?
Well, I have flown to space one time, and I have not come home yet, so I'm not really sure. Now, I've heard a lot of stories. You know, anything from the spinny cup at the fair to a roller coaster ride. You know, when you think about it, it's a pretty sporty event, because going from 0 to 17,500 miles an hour was pretty sporty. That took about 8.5 minutes. But going the other direction is no small feat. And so what we do is we have these aerodynamic shaped vehicles that are kind of like a candy corn shape, and we come in at a really shallow angle to Earth's atmosphere, and the biggest thing that slows us down is the atmosphere itself. And so it would be like, you know, when you're skipping rocks, and if you skip a rock at a really shallow angle, but instead of skipping off the water, it goes into the water. Well, now think about something going like the speed of a bullet and then just grazing into the water, and that slowing down motion, that can be there can be a lot of vibration. It's a lot of heat. You know, we have very protective heat shields on us so that the metal doesn't melt. Only certain materials can even withstand that. In fact, in the future, when this space station is finished being used, it will come down and re-enter the Earth's atmosphere, and it will disintegrate at that point. Even with all this steel and metal that we have, there's no heat shield on it. And so it can be a pretty sporty event. And once we get through that, then we're under parachutes. And I'm sure you've seen people, you know, parachuting. That can be, you know, you can swing under the chutes, and you're feeling gravity for the first time in 6 months. So, so I'll have to answer that question from personal experience later, but that's what I know of it right now.
Hi, my name is Melania, and I'm a student of Coconino High School. My question is, how do bubbles act in zero gravity? Do they float in place, or do they float up and stay alive for a while?
So to answer that question, you got to think about what causes a bubble to pop on Earth. Let's say it doesn't hit anything. It still eventually pops, right? So a bubble, if you take like a soap bubble that floats in the air, it's a hollow with the soap around it. Well, eventually on Earth, the gravity will pull that soap down to the bottom of the bubble, and it pops and becomes a drip, right? Well, up here, bubbles will last longer. Now, we're in a smaller space, so it's probably more likely it would hit something, but it would actually last longer because there's no gravity that would pull the soap off of the side of that bubble. So it just kind of sits there. So that would be like a hollow soap bubble. Now, we are highly encouraged to play with our food here in space, and we like to do this because this is like physics principles in action. So let's see if I can do this without making a mess. I'll make a bubble for you. Hopefully you can see that. So surface tension right now is keeping that bubble attached to the straw. And surface tension is kind of the only thing that keeps us from being total slobs when we're eating. But if I pull that away, now it goes in whatever way the original force went because there's nothing to stop it. There's no gravity. And I better drink that before it hits something electronic. So, so the difference is that they will keep floating until they hit something. They will never come down.
I think we have time for one last question. No, I'm sorry. That was our last question that we had time for. Astronaut Ann McClain, thank you so much for your time and for answering our questions. Coconino High School and Flagstaff Unified School District wish you safe travels and best wishes for a successful mission on the ISS.
Station, this is Houston ACR. That concludes the event.
Thank you to at all. Thank you to all participants from Coconino High School Station. We're now resuming operational audio communications.